Hi guys, this is a video overview of the source code for the Test Electronics FixtureduinoMini. This is open source software free for you to download on our website and use as you see fit or not use at all. It's available to help you get your FixtureduinoMini up and running quickly and easily. If you don't know what a FixtureduinoMini is, you should probably view the hardware version of this first. Before you view the software. It'll give you a much better idea of what this software is supposed to accomplish. But basically, a FixtureduinoMini is a bed of nails test fixture that tests circuit boards that uses the smaller Arduino boards as the test engine. The FixtureduinoMega uses the large Mega Arduino Mega board. The Mini uses the smaller ones, which are the Duomilanova, the Nano, and the new Uno. This is version 2.0 of our open source software, which is basically a framework and a demonstration on how to write tests. Version 2.0 is a big jump above all the past versions in the 1.x series, just released in 2013. Version 2.0 cracks the barrier, the 2K static RAM barrier that was hampering development with the smaller Arduino boards. The Mega has 8K, but the smaller ones all have 2K, and it was really hard to do all the prompting necessary to run a long series of tests. Because the developers at Arduino came up with a way to store these large static RAM memory hogs, long text strings and character arrays, into flash memory. Flash memory has 32K of memory. 1K of the flash memory is used by the bootloader. 31K is left for us to store text arrays and text strings in, versus the old 2K that we had to store in static RAM. Now we have 31K, which gives us a lot more opportunity to store prompts, text strings that have to go out to the LCD display, enabling us to make much longer test routines. This basically allowed us to create this whole new framework with all these options that were previously only available in the Mega to be imported and used in the smaller Arduino boards. So let's go over this FixtureduinoMini source code. So starting with test number 1, this is where we load the array of characters into static memory. Flash memory, flash ROM. This is the title of each one of the tests. There are 11 tests here, and the array of 11 tests, and here are the 11 tests. Here's the last test where it turns power off, and here's the test map where it starts with test 0, turns power on, and then runs through test 1, 2, all the way up to test 11. And here are the tests, starting with test 1. This is where in our demonstration program we turn the relay off and measure 0 volts across the voltage divider. Then in test 2 we turn the relay on and measure 2.5 volts across the voltage divider. Also in these two tests we demonstrate how to skip them if we're not in the full test mode. There's a full test mode and an AQL mode, which is acceptable quality level. And a few tests that we consider might be reliable, such as resistors, are skipped in an AQL test, which allows you to speed up testing on tests that you only might want to make, say, 1 out of 100 times and skip 99 times. Or whatever your acceptable quality level is in your ISO standard, if you're using ISO. So that's what that is all about. And it is used again here in test number 6, where it skips the resistance, skipping the discharge of the capacitor, the test that discharges the capacitor. We basically test the capacitor by charging it up here, but this is just a demonstration You decide for yourself for your own tests what tests you may want to skip and what tests you want to test every time. Now in tests number 3 and 4 here, we demonstrate how to charge the capacitor. Well, basically we're measuring a voltage on a divider with a capacitor across it, so it's designed so that it's going to fail the first test, to demonstrate failing and then retesting automatically behind the scenes so that the test technician doesn't really see it. Because sometimes you may have something that reacts kind of slow and you might want to slow it down and test it again, and this is the technique you would use. Now for tests 3 and 4, the way you do this is you go here to internal and where it cycles through the testing, the test cycle, and you go on this line. You would define what tests you would like to retest and what parameter you want to change when you retest those tests. So then it'll go through and test those tests again, change the parameter and go through those tests again, and then give you a test result. It runs test result. Test result is up here, and what this will do is when it gets down into the pass, it tests if the charge delay was increased. Well, we increased it to 4,000, so it was above 3,000. So it's not going to print this, it's going to print this. And if you're wondering what this means, this is printing on the second line of the LCD. The first line is 0, the second line is 1. So it's printing on the bottom line of the LCD, and it's printing number 5 of the array. So you go up here and you look in what's in number 5 and what's in number 4. Number 5 is when it passes, it prints this. If it doesn't pass the first time and it passes the second time, it prints this. Now there's just a little tiny difference that the test technician is not going to know, but the test engineer will recognize. And this is just so you don't have the test technician someday dividing the test results into 3 piles. You always want them to put a test in a pass or a fail. You don't want them to put it in a pass, a kind of pass, and then a fail. Sometimes they'll have a tendency in certain situations to make up a second batch, and then you just have to say, okay, move all those to pass because that's really a pass. The reason it failed is not a reason to fail the units. But that's what that's for. You could also put a warning message in here, but think about the 3 piles at the end of the day scenario. You might just want to trick them into thinking it passed and just know for yourself that it had to retest there. Okay, now back to the test. The next thing I would like to demonstrate is the press any key to continue function. It's basically a pause. It's right here in test number 8. It pauses until you press any key. Now this can be in the settings. You can set this to pause for a certain amount of time or wait for the operator to press any key. And the press any key function is back in the end because it's one of the last functions that it has to cycle through. So press any key is here, and it has to go through all these functions. Serial available is the Bluetooth or the serial port if any serial data has been entered. So if you have sent anything through the Bluetooth remote, it'll trigger it. If you send anything through the infrared remote control, it will trigger it. The analog keypad on the front will trigger it. Voice will trigger it. There's a voice actuated switch. Now this is the same thing for you who are new at programming as saying equals 1. Just if it is 1, if it returns, this program returns 1, then it's going to set x equal to 1, and it's going to exit this loop. It's no longer going to be equal to 0, so it's going to exit the loop and continue on. So let me explain a little more about voice. What's this function and what's this number mean? Voice is back in internal, down here, voice right here. This is the voice function. Basically what it does is when it calls the voice function, it cycles the mic through 100 times, does 100 tests on the mic. If it gets hit more times than what's on this, so if we passed a 10, if it gets hit more than 10 times, it returns a 1 and says that it received a voice. Now if you want to, right here is the description on how to use it. So if you want to use it, I always try to comment a usage description. If you want it to be less sensitive, you would increase this value, say to 20, and then you'd have to say test instead of just test. And if you decreased it to 1, it'd probably trigger on a pin drop. Decrease it to 5, it'd probably trigger on the snap of a finger or something. But 10 is a good setting. If you have a lot of background noise, turn it up to 20 and it'll work better for you. Now back to test again. Let's go through the rest of the tests. Tests 9 and 10 are just kind of demonstrations. This test is fake but demonstrates display technique. It just shows you basically in simple forms how to display data out to the LCD and serial, Bluetooth and out the LCD. Now this way of displaying data used is a really clean way to do it and makes the test easy to follow and less cryptic, but it uses a lot of memory. Now if you're only making about 20 tests or so, then this is fine, but if you want to make more than 20 tests, then you need to put this into an array or you will run out of static RAM in your Arduino, in your small Arduino board. So you'll have to make another array like this. And you have to name it something different. This array is named test H1 buffer. You'll want to name it something else. There's examples on different names of arrays all throughout this. Here's the debug. Then in preferences we have this large array, and they're separated by spaces because the different programs in this array are called in these grouped together in this space. But basically it's easier to write tests with the character string in the test so you can see exactly what your test is doing, but it'll hog up a lot of memory if you have more than 20 tests. So keep that in mind. Now the last test, test 11, just turns off power. Basically it takes this from the array, the title, and displays that and then shuts power down. Now you could, instead of having a test 11, you could just put in here power off, and then you'd put a 1 to show that power is off. But what that would do, instead of displaying 11 power off, it would just display power off, UUT. So to make it cleaner, we put the 11 power off in here and made it a title and made it a test. It just makes it follow the sequence more and a little bit cleaner looking. So change this back, test 11, and take the parameter out. There you go. I'm not going to save this anyway, but that's how it should look. Now this concludes the overview of the basic tests, and in the next video I'm going to go over the test subroutines and the test debug. Hope to see you then.